Let's talk about some basic collision detection in pygame. So we're going to start with a set of tasks to accomplish. Let's create a 640 by 480 window. Create a blue square at 150, 150. Again, remember in pygame, the upper left-hand corner of a square gives the location. Let's put a red square at 0, 0, and then have the red square begin moving down and right toward the blue square. When the red square touches the blue square, we want the blue square to turn purple. Then when the red square has passed through, we want the purple square to turn back to blue. So let's look at one way to complete this set of tasks. So we're just going to include the line-by-line description of what kind of code will achieve this. There's more than one way to do this, of course. This is just one particular approach. So we import pygame. We can initialize pygame. We can often leave out the initialization, but it's safer to go ahead and include it unless we really care about the resources. If we really care about the resources, then we can select exactly which modules of pygame that we need to initialize. Otherwise, for now, for our purposes, it's probably safer just to go ahead and initialize pygame in this general kind of way. So we created a screen to present things 640 by 480 pixels. I put a background in place so that we can have the drawing portions that don't move versus portions that do move. I went ahead and filled this in white, and then we do the background.convert to make blitting a little bit easier. There are some other aspects that we realize are going to change. So in our program, we could include the color, setting RGB values. We probably want R to be 0, G to be 0, and B to be 255, since that is the value that is going to stay fixed, at least for a while, for the blue square, and then it will change later. So in this case, we could put 255 instead of 0, and that way the initial RGB values would make a blue square. We also have the red square starting at 0, 0, so we set x to 0 and y to 0, and that's going to change as the square moves. Then those x and y values, we can update those. Since we said we want the square to move down and to the right, we can also set a change in x value and a change in y value, so a dx and a dy. If we set both of those to 1, then the square will move down and to the right in a uniform way. If we change one of these values or both of these values, then the red square would move in a different way. We also want to set a frames per second, so we can use pygame.time, create a clock, and then tick the clock according to the frames per second. All right, then we're going to have a main game loop, and we set that to true, and when we want to exit the main loop, we can change that back to false. All right, so we will set up a while loop, while main loop, and outside of that loop, we will quit pygame, and everything else will be filled in between inside the main loop. So we can, again, tick the clock according to the frames per second so that things move at a speed that we like. Then draw the background. So we're drawing on what we want, and at the bottom we will need to flip so that we can see that eventually. And again, everything else will be going in between. There can be a discussion about whether to use flip or update. If we're using update without anything in parentheses, then flip is a little bit better choice. But if we had multiple surfaces and we just want to update specific surfaces during the loop, then update with those particular surfaces selected is a better way to do things rather than updating everything, updating the specific cases. But in this particular case, we only have the two squares and only one of them is moving. The color of one might change, but otherwise everything is staying fixed. And so flip is the reasonable choice at this point. Now, in general, we want to include things to be able to close the window so that when we're testing, we can always close the windows with no problem. So we can close them by clicking the X. If we click the X, then set play to false. The break, actually, I'm sorry, that shouldn't be play, that should be main loop. I changed my variable name, so this should say main loop. And then break, which will break out of the for loop and change the main loop value to false. Otherwise, if we have a key down, in particular the escape key, then the same thing. And again, not play, this should say main loop. All right, now we can draw the blue square. It's a rectangle that we're drawing on the background with the RGB values. Again, whatever, if we didn't want it to be blue, we could have changed the R, the G, and the B earlier. But at this point, we have R is 0, G is 0, and B is 255. Then we set the left-hand corner, the upper left-hand corner at 150, 150. It's a 50 by 50 square, so draw it at 50 by 50. And then in this case, we're just emphasizing that the square is filled in. So putting the 0 will guarantee that that square is filled in all in blue. Then we're going to have a moving object, which again is another rectangle. This one we're going to draw on the screen so that we don't get a trail left behind. Make this one red and set the X and Y values according to the 0, 0 right now, and that will update as we go forward. So then what happens? We want X to change, X plus equal dx, and then Y plus equal dy, so that at each time through the loop, then the X and Y values will update accordingly. At this point, they're going to update, again, dx and dy are each 1. We can use the built-in collision detection. We have collide rect. There's some other collision detection that's built in that we can talk about later. But if moving object collides with the fixed square, then what do we want to have happen? We want the color of fixed square to change. It's given in terms of an RGB value. Right now, B is 255. So to make it purple, we could set R to be 255 as well, and that's going to be a purple color, a mix of red and blue. We can make a choice. We can change those values a little bit to get a different shade of purple. But that's the only thing we need to do. If the collision happens, then let's change the color, add some red into the blue. Otherwise, if the collision is not happening, we just make sure that R stays 0. This is going to happen each time through the loop. Even beforehand, when R already was 0, we check to see if there's collision. If not, we set R to 0, even though it was already 0 originally. This is so that once the color has changed and the square is purple, after the collision no longer occurs, then the red goes back to 0 and it's just blue and the square stays blue. All right, and that's all we need to do. Check for the collision, change the color if necessary, otherwise draw the picture, and we have the red square would move across and change the color of the blue square when there's interaction. All right, so if we don't use built-in collision detection, then we have our program, and that portion with the collision detection we need to replace with something else. So if we want to do the manual collision detection, we just need to check the values at the X and the Y values. From the upper left-hand corner, if the upper left-hand corner has passed the vertical line at 150, so if X plus 25, which is the right-hand side of that square, if it has passed the left-hand side of the blue square, and not gone too far, right? So it's still to the left-hand side of the right part of the blue square. And then the Y values are also appropriate. So the Y values are between the Y values of the blue square. Then we change the color, and otherwise we don't. So the collide rect is basically doing these checks to see, is there overlap both in the X and the Y direction? So we can do this in this case without using any of the built-in, just doing the checks ourselves and creating the color change if necessary, and then not making that color change when it's not necessary. All right, so let's look at a modification of the problem. Now let's create the red square. Instead of in the corner, let's move it down the screen and create it at 0, 160. And then have the red square move toward the blue square, which again will still change to purple as the red square is crossing over. So what changes are necessary in order to make this modification? So for this modification, the only changes we need to make are the values of y and dy. We set y to be 160 in our original portion of the program before the loop, and we set dy to be 0, and that way there will be no vertical motion of the square on the screen. It will just move horizontally across the screen toward the blue square. And other than that, everything else works exactly the same way. So for our second modification, we want to change the red square to a red circle instead and have the radius similar to the side of the square so that the red circle is roughly the same size as the square. Not exactly, a little bit smaller, but roughly the same size as the square. Remember again in pygame that the radius needs to be an integer. So we're looking at a radius of 12 or 13 instead of a side of length 25. Then remember that a circle, its location is given by its center rather than by the upper left-hand corner. So we want to look at this from both perspectives, this circle being on the left side of the screen where we had it before, where we had the rectangle before, the red square, or in the upper corner, in the upper left-hand corner in the same way. So two parts. Having it on the left side of the screen moving straight across is the slightly easier version of the problem. In the corner moving down, we'll have to think about things a little bit more carefully. We still want the red circle to move toward the blue square, and the blue square change to purple, just like we've been doing so far. Whilst the circle is overlapping, the blue square turns purple. So let's think about what changes are necessary there. Once we create the circle instead of the rectangle, using the collide rect method, or the other way, the manual version of that, mostly works just fine. Turns out that there is a rectangle associated with the circle. When pygame creates the circle, it also creates a corresponding rectangle, so we have the circle. And we have a rectangle, which is a circumscribed rectangle, goes around the outside of that circle that is associated with the circle. And so the collision detection is happening in with regard to that square in this case, but that rectangle. So if we were moving straight in from the side, then this side of the rectangle is being detected. If we were moving in from the top and so on, the same kinds of things would be going on. If we're coming in at the corner in this way, moving down and to the right there, we notice that there's some gap. And so the detection would appear that the circle had intersected this square, but actually there's a gap before the circle gets there. And so the method mostly works fine, except for that issue. So the rectangle can be thought of as a bounding box, and that's where the collision is based on that box rather than on the circle. And we've already mentioned what can go wrong if you are just considering the collision of the box, then the circle itself might not be there yet. So the color of the blue square would change a little too soon to purple, and then it would change back to blue a little too late after the ball had already passed through. So we will develop some other methods to improve on that. Some of those you could probably think about and come up with, but we will add some new techniques using some of the new mathematical skills that we will develop, some of the tools that we will build over the next few labs, and then be able to improve this collision detection between circles and rectangles, and also between two circles and other shapes as well. So as usual, if you have any questions, then look me up on Discord or send an email and let me know how things are going.